And number 3 from the Chapter 6 homework. This problem reads that a 6-year semi-annual coupon bond is selling for $991.38. The bond has a face value of $1,000 and a yield to maturity of 9.19%. What is the coupon rate? Okay, so now the rest of these problems are just going to be missing one piece, right? You've got the N, I over Y, the PV, the payment, or the FV. That any one of those could be missing, and you're going to have to solve for the missing one. Okay, so part of the trick here is just learning to read the problem and know what you're looking for. If you want to find the coupon rate, it's going to be in terms of percentages for a bond, because that's how they're quoted. It's part of the vocabulary that goes with them. But you know what that is when we talk about the coupon rate. It describes what the annual payment is, the annual coupon payment on that thing is. So when we set it out on a timeline here to make it a little more clear what we're looking for, what we've got is the present value. It gave us that in the problem when it says the bond is selling for $991.38. That's our present value. We know the future value of the bond. It's always $1,000 right here. We know our N. It tells us that it's a 6-year bond. Okay, so our N here with semi-annual payments is 12. The 6 times 2, 6 years times 2 is 12. So what we're looking for here is the payment. Right? We want to know, and what our calculator is going to give us is the semi-annual payment. And the problem is asking for the coupon rate, so we'll have to convert that to an annual figure. But that's easy enough that we'll do in step 2. Okay, so let's plug in what we know into the calculator. I'm going to clear out the previous problem here by hitting second clear TVM. And plug in what we've got here. Our N is 12, so 12 and then N. Our interest rate that it tells us, our yield to maturity, is 9.19%. Remember, we got to divide that by 2, because with all bonds, we've always got semi-annual compounding. So our interest rate and our compounding need to match the number of payments per year that we're getting. So 9.19 divided by 2 equals, okay, we've got that 4.595. Store that as I over Y. Present value, I know. It gave that to me in the problem. And be careful that you make this, the perspective I'm picking again is me. If I were to purchase this bond, I'd have to pay $991.38. That's a cash outflow for me. I want to make that guy negative and store that as my present value. Payment is what I'm going to be looking for. I want to know that semi-annual coupon payment. Okay. Future value is $1,000, and that's going to be positive. If I were to purchase this bond, that'll be a cash inflow to me that I'll get at the end of 6 years. So make it a positive $1,000 for my future value. Then I'm going to hit compute payment. All right, I see a positive 44.99, so I'm just going to go ahead and round that to 45. Right, and that's a positive payment because I picked my perspective, so I'm going to receive that payment every 6 months if I were to purchase this bond. But that's what I'm going to get every 6 months. Right? We want to know the coupon rate, which is always stated as an annual rate in the problem. So in step 2, what we've got to do is do a little conversion here to get the actual percentage rate. And all I've done is rearrange this formula from number 3, where we've got the coupon payment equals the annual coupon rate times face value divided by 2. I've just solved this for the coupon rate. Right? So multiply 2 over to the left-hand side and then divide by face value. And that's all this is a rearrangement of the formula that we used above in both number 1 and number 2. Okay, so I can just plug in what I've got now. Okay, the annual coupon payment is the numerator here. Well, that's the 45, which is the semi-annual payment, times 2. Since we get that twice per year, if we just multiply that by 2, we'll get our annual payment of $90 in the numerator here. Divide that by 1,000 in the face value, and you get 0.09. Okay, so the coupon rate is 9% on this bond.